Hello, in this episode of Exploring Rust, we're going to take another look at the dyn keyword, and we're also going to take a look at the box clone pattern. This is again something that I found I needed just in the course of trying to write a Rust application. So it's definitely something that's useful and that I think you're going to want to use if you get into any serious Rust programming. First, let's create a trait. I'll create a really simple trait which I'll call value, and that's just going to have one method associated with it. So we have a reference to self in there, and we're going to return, let's just return an F32, floating point 32-bit number. So what can we do with this? Well, we can make, for example, structs that implement this trait, and they are all going to have a method called get that returns a floating point number. So let's create a struct here, which I'll call pi. And let's give that one field, which can be of type F32. I'll put a trailing comma there, that's optional though. Then I'm going to add some implementation for the pi struct. And I want to give it a kind of constructor, which I like to do. So let's give it a function new. This is an associated function technically, I think. That's going to return self, which is basically a synonym for pi in this context. And we'll put the brackets in there. And we can create an object directly here which will return. So again, that's a synonym for pi. And we just have to fill in the value of this one field that it has. So let's put value is 3.141592. That'll do. Put a trailing comma in there too. So now I'm going to implement this value trait for pi. So let's say impl value for pi. And then what do we do now? Well, we've just got to implement this one method. So let's paste that in there, put in the brackets, and that can just return self.value. As long as we don't put a semicolon there, this is going to be the return value of this function. So assuming that I've got everything right, we should be able to use this stuff. Let's say let pi equal pi : new, and then we can do print line and print something out like value is, put some curly brackets in there, and pi.get. If I've got everything right, this will now work. So let's switch to a terminal and do cargo build. I'll do cargo format as well, and let's do cargo run. And we can see that we've got the value being printed out there. So this definitely represents a significant improvement for me on how I was doing previously with Rust, because now I'm able to at least type a small program like this without any mistakes some of the time. I'm just going to turn off this header feature in Visual Studio Code, if you can see that. I don't really like it because it makes the screen look a bit confusing, but I think if I go to header or something, I don't know, or view preferences maybe, view appearance sticky scroll, is that it? Don't know. I think that's worked. Yeah, seems like it's gone. I don't really like this minimap either, to be honest. Let's get rid of that while we're here in Visual Studio Code. So that's this. Yeah, that looks better to me now. So we've got an object or a struct that implements a trait. And a normal thing to do in most object-oriented languages would be something like this. Instead of just having one pi, we could create a vector that could contain anything that implements this value trait. And then we should be able to call the get method on anything in that vector. So let's actually try it. I'm going to say let values equal, we'll use the vec macro here to create a vector. And in here I could put pi : new. And then we could loop over that. So for v in, and we want to get references to the values in the value vector one at a time. And then we can just do, well, I can use this now. So let's move that up. And instead of accessing pi, we should be able to access v. I think this will also work. So if I switch to a terminal and run it, we still get the value coming out there. And we could add more pi's in there. What we can't do though is add something that isn't a pi, because the type of this vector is going to be inferred to be a vector of these pi objects. And what I would like to do is have a vector which has the following type. So it's going to be a vector of value. And this actually doesn't work. So let's just try it and we'll see what issues come up. And it it's basically saying I should add the dyn keyword in there. So what's the expectation that I've got here? My expectation is that I can put other things in this vector that implement this value trait, and then I can call the get method on all of them, and the correct get method will be invoked. So if I've got a pi in there, I want the get method of pi to be invoked. If I create something else that isn't pi but also implements value, I want the get method of that thing to be invoked if that's in the vector, and I get it out and try to call get on it. That's a very, very normal typical thing in, for example, Java or Python. But you don't get this behavior out of the box with Rust in this way. So what I have to do for a start is put the dyn keyword in there, and that basically, as I understand it, implements the virtual table and the other things that are needed to make this kind of behavior work. But we still get an error even if we do that. So if I clear this and then run it again, it's complaining that this vector doesn't have a size that's known at compile time. So the issue apparently here is that with Rust vectors, Rust has to know the size of the vector at compile time. So it has to know the size of everything in the vector at compile time. And it doesn't necessarily know this if you do this, because I could push more things onto this vector that implement the value trait, and they could have different sizes. And then we've got a vector of things of sizes that are not known at compile time. What Rust wants to do is create a vector where everything is stacked neatly next to each other in memory. And it can't do that here, because I might push almost any old thing onto the vector as long as it implements that trait. So we can solve this by, instead of storing the objects directly in the vector, we just store pointers to the objects. And we can create a thing called a fat pointer by using box. So instead of having a vector of dyn value, I can make that a vector of box dyn value. And for each value, I just have to box it up with box new. So I pass it to the constructor of box. And this is apparently called it's a kind of smart pointer, and it's apparently called a fat pointer because it doesn't just refer to a memory address, it also carries some metadata. And now, if I run this, it actually works. So I could now create more things that implement this trait, and I could add them to this vector, and this behavior, this polymorphic behavior that we expect in object-oriented programming, would actually work. But let me show you something that still doesn't work. I'm going to rename this to values 1. And another fairly typical thing to do would be we might want to clone this vector and everything in it. So I might want to say let values 2 equal values 1 dot clone, and then I might expect that if I iterate over values 2, I can also call the get methods on things in values 2. But this cloning behavior doesn't work. Let's try running it and see what happens. I'll do cargo format and then cargo build. And it's got kind of an error message that, to be honest, is a bit cryptic. It's saying method cannot be called on vec box dyn value due to unsatisfied trait bounds. The following trait bounds were not satisfied. Box dyn value clone. And it's basically saying it doesn't know how to clone this vector. Rust does know how to clone vectors. It just doesn't know how to clone the things that I put in the vector. Because what does it know about those? It knows that they basically are boxes that point to something that implements the value trait. How do you actually clone that thing? It doesn't know how to do it. So what we have to do is we have to implement clone for box dyn value. Because if clone is implemented for that, and it's also implemented for vector automatically, then it can clone the vector. This I found quite confusing for quite a long time, but I think I've finally got my head around it. So let's do impl clone. So we want to implement the clone trait for, and we actually want to implement it for the whole thing that we're putting in the vector, like this, so that that can be cloned. So to implement the clone trait, we have to have a function clone, and we want a self-reference here, and that is going to return, well, in this case, it's going to return something of this type. I can put brackets in there. And now what could we actually return from this without thinking too much about how to properly implement it just for the moment? One thing that we could return from that is a new box that's wrapping a new pi. I think that should work because this satisfies this type. So now our code should actually compile. Let's try it. Okay, so if we build this, then it does actually build. And if I run it, it sort of looks like it's worked. So this is iterating over the second vector. Let's actually put a print line in here just to create a blank line between these two sets of output. I'll just clear the screen. Let's do a cargo format. It's always good to do. And then if we run it, so you can see that we've successfully iterated over both vectors and it looks like we've cloned them. But we've cheated because when we clone a vector now, we're always going to be putting pi's into it, and we might want to have other things in there. So this isn't really a good thing to do. It's not very useful. It's always going to, it doesn't matter what vector you clone, it doesn't matter what things it has in it that implement this value trait, we're always going to get back a vector of pi in this case. How to fix that? And this is where the box clone pattern comes in, which did take me a while to get my head around. It's the kind of thing that you kind of probably have to type out yourself so you sort of see how it works. But hopefully this video can help if you're stuck in the same situation, which you will be if you do much Rust programming, I think. So we've got a reference to self here, and what if we made it so that everything that implements value has some kind of a method for cloning itself? But we don't just want it to clone itself, we probably ideally want it to actually clone a version of itself wrapped in a box like this. So if I go to where I declare pi, I could make pi clonable just by, in this case, putting #, couple of square brackets and derive clone right here. Because it's a very simple struct, it's got no pointers here, this can just work out how to implement the clone trait for pi. So now we can clone pi, but what I also want to do is, for trait value here, I'm going to say function clone underscore box. And that's going to take a reference to self, and that is going to return a box containing a dyn value like this. Now when I implement the value trait, I have to implement this as well. So I'm just going to copy that and we're going to implement it for pi. So where I do implement value for pi, I'm going to paste this in and we're going to return a new box with a cloned pi in it. And I could just call self.clone to do the actual cloning of pi because I put that there. But of course you're free to implement clone for your structs and you can make clone do whatever you want. If this had pointers in it, I'd need to create some kind of more sophisticated clone, depending on whether I wanted to just copy the values of the pointers or copy the things that they're actually pointing to, or what I wanted to do. So now, in my implementation of clone for box dyn value, and box dyn value, remember, is the thing that I'm actually putting in my vector, here I can just call self.clone box like that. And that is going to invoke this, which is going to clone a thing of the correct type. So if I've got all this right again, then this should still work. Let's try it. And you can see it looks like it's working. But the acid test now is, can I then implement value for other things and put those in the vector, and will the vector be correctly cloned? So let's create another struct here. I'm going to create one very similar to pi. So that's basically all this stuff down to here. And normally I will put these different implementations and structs in different files, but I'm just putting it in one file to keep this simple. Let's create a copy of that, and I'll create struct, let's call it surprise, and I'm going to just copy that, and we're going to put surprise here and surprise there. And let's make the constructor take a value. So let's have value of type F32, and then I just need to put value in there like that to get this here. And now I think if I've got everything right here, this should work for this as well. This implementation of clone box is fine for my surprise struct here. And I'm just going to create a surprise struct and put it in the vector. It does implement values, so we should be able to put it in there. Let's say here box : new, and in there I'm going to put surprise : new, and let's put 1.23 in there, something easy to remember. And then if we do maybe cargo format and cargo build, it should build hopefully, and then cargo run, and you can see everything's fine. So we put into this vector a pi and one of these surprise things with the value 1.23, and we iterate over the first vector and we get pi and 1.23, and then after cloning the vector we've also got 1.23. So I think that's pretty nice. Is there something different that we could have done here? Could we have, instead of using clone box, maybe just use clone? I think perhaps we could have, and then we would have just had to wrap this in a box. But I think this pattern is pretty nice, and it makes it clear what we're doing here, I suppose, that we actually want to clone something which is going to be wrapped in a box. So there is that. It's pretty clear what's going on with this. Okay, so I know that's quite complicated, but I think this is definitely, for me, this is going to be very useful, because I've run into exactly this situation where I've got a vector of values that implement a trait and I want to clone the vector. So you'll probably run into it too if you do much Rust programming. I'm going to put a pretty detailed write-up of this on blog.caveofprogramming.com, and you can also watch the video there if you prefer, without any ads. So until next time, happy coding.